even do the yeah, cool. Looks like we are live. Are we good? Yeah. All right. Okay. So welcome again, everyone. Thanks for joining the session. Today we are going to talk about one problem that we had been working on as part of our Go bootcamp, and we try and live code this problem using test-driven development. Yeah, let's get started. So this is going to be a three-part series where there's going to be three sessions. The first one is today, right now. We'll have next one on 13th and other one on 20th. Today's agenda is mainly to cover what is the problem we're going to talk about and implement the first three stories. As we discussed earlier, use Slido for feedback and any questions, etc. Because we have sort of less time and a lot of ground to cover. Right. So the overall agenda is that we'll talk about this problem, which is migrating data from MongoDB to Postgres. We'll figure out how do we break this problem down into smaller stories, which is the sort of most essential part of doing test-driven development. We'll actually have a live coding session. We'll in this is what we'll cover today. And in the next two sessions, we are also going to touch upon the sequential solution to this problem, where we have a single data pipeline with a single Go routine doing all the work one after the other. What we look at after that is something called as Amdahl's law, which is pretty interesting. And we'll try to introduce worker pools later to be able to solve this problem and see the challenges of worker pool and why we can't just throw worker pool specifically at this problem, right? And then we'll figure out another orchestration solution for this problem, and then we'll have the takeaways. For this session, today's session though, we are going to cover the first 3 points, which is the problem, how do we break it down, and live coding for the first three stories. All right, so what is the problem really? We want to migrate data from MongoDB to RDBMS. Think Postgres. Now you might say, okay, what data do we want to migrate? What do you mean by migrate data? Is it one time? Is it continuous? How many tables or how many collections and how many databases do we have, etc. Right? We come up with all these questions. So what we want to do is we want to think about this as a obviously ETL process, but think of it more like a continuous streaming update. This is based on a use case that I had worked on a while ago, where one of the organizations was using MongoDB as a primary database, and they were running analytic queries on Mongo, which was proving to be a bit slow and causing a lot of CPU utilization and making the actual production database slower. This is where we decided to use something like this, where we wanted to migrate data from MongoDB to PostgreSQL and run analytics on top of PostgreSQL. Now, first question that comes to mind is Mongo is document database. It's JSON document, and it can be nested JSON documents in a collection. So what do we mean by migrating this data? What we wanted to do was that we wanted to ensure that any nested JSON documents get mapped as separate tables in Postgres. I'll cover that as we go along. But for now, consider this use case to be migrating data from Mongo to Postgres in a real-time fashion. So what we use for that is oplog. If you've heard, if you know, Mongo has a concept of a oplog, which is called operations log. It looks something like this. It's a capped collection, a separate collection in a local database in Mongo. A sample record in that Mongo collection looks something like this, where you have an op as operation, which is if transfer insert, the namespace. This means there is a test database and a student collection, and this is an insert record in that collection. And here is the Mongo object ID and a bunch of JSON fields that are being inserted in the student table. What we want to do when we migrate this data to Postgres it should look something like this. On PostgreSQL side, a schema test will be created, which corresponds to the database test here in Mongo. A table student will be created, which corresponds to the collection student in Mongo. And all of this data will be mapped to appropriate columns in the Postgres with appropriate data types. For example, graduated will be Boolean, roll number will be integer, these will be strings. We have a full-fledged problem statement that we get to, but in a nutshell, this is what we want to do. Now, in order to actually live migrate this data, we also need to create the schema, create the table, and insert data into this table. So this entire problem statement revolves around doing that. By the way, there is already a tool called Stampede, which exists to solve this problem. It's written in Java. We've used that tool in the past. Here, our attempt is to create something similar using Go and almost like a 0.1 version of that tool to be able to learn system programming, system design, concurrency, etc. That's the goal. So what we will do is we're going to write a program that parses Mongo oplog entries. Think of oplog as a write-ahead log in case of Postgres, but for MongoDB. Right? This is where all the transactions that are happening in Mongo are written down to, and then these are replayed across various Mongo database nodes. So we're going to write a program that parses these oplog entries. We convert these oplog into some sort of SQL form, and we're going to execute this SQL on Postgres. And this has to run in a streaming fashion, something like this. So we're going to have a Go routine. Each of these gophers, think of them as Go routines. We're going to have a Go routine that reads the oplog from Mongo. It pushes these oplogs onto a channel of oplogs. There's going to be a separate Go routine which processes and converts these oplogs to SQL. This is where most of our business logic will lie. And out come the actual SQL statements, which will be put into, let's say, an SQL statement channel, and there'll be a Go routine which executes these SQLs against PostgreSQL. This is an example of a data pipeline kind of a problem where we are taking data from one form, we are transforming it to another form, and we are writing this to a separate third form. So classic extract, transform, and load kind of a data pipeline. Okay. Before we move on to the live coding, I want to talk about the problem statement a bit. So this problem statement is available publicly. You can go to this website and see the problem. I hope some of you have already read that, but if not, we're going to quickly cover what we're trying to do, right? So as we said, there is a oplog collection, which looks something like this. And one sample entry in this oplog collection looks like this, right? Which is what we just saw. So we said that oplog indicates the type of operation, NS indicates the namespace, and this indicates the operation being performed, the actual data for the operation. Okay. What we have done though, to be able to start with test-driven development for this, we've spent enough time understanding this problem statement, brainstorming it, and breaking it down into separate small stories, right? If you think about it, this looks like a full-fledged project to build, where you have data in Mongo, you want to move this into Postgres, and you have to also cater to a lot of business logic requirements, where how will you map nested Mongo, nested documents? How will you map names of collections to tables in database and whatnot, right? So this is where we have broken down this into multiple stories. What we are going to cover today is the first three stories, which are pretty simple to start with, where we're going to parse the insert oplog and the update and the delete oplogs and convert just that into the equivalent insert, update, and delete statement in Postgres. We'll not worry about the creation of tables and schemas just yet. Again, to keep things simple, we'll do that later in the other stories where we create a table where there is one oplog entry, We create table when we are passing multiple op logs, etc. Right? So these are the like first 9 stories is what we're going to cover in the next in these overall 3 sessions. Right. So yeah, without further ado, I'll let Kalpesh present uh, the screen, and then we'll start with a empty repo where we're going to start writing the first test, and we're going to start thinking out aloud, and Kalpesh is going to sort of explain how we will actually start writing the test case and what should we go ahead with. All right, over to you, Kalpesh.
Okay, thanks, Chinmay. So, hello everyone. Let me share my screen. Okay, so for this live coding, we have created one repo, and it's a public repo. We will commit as we go with the implementation. I will push the code to this repo so that you can refer it later. I have cloned it at my local. So before starting any kind of problem, I would always start with creating the hello world program so that it makes to make sure that my setup is ready to start with. So I'm just creating the main function here. Just I have this copied to save the time. I have created the code. Okay, so our hello world is running fine. Now come back to the problem statement itself. So the first story is about parsing the insert oplog, and this is the oplog as Chinmay said. So we have this oplog as a JSON. Now, before starting to as a TDD, we are going to follow this problem statement to solve using TDD. Before starting, we don't have anything. Now, to begin with, what exactly we should start with? So first, I would write down some the what is the story basically. The story is to parse this JSON and convert it into the some SQL statement, right? Now we need to think of this. We need to figure out the list down the happy and unhappy path first. So that what is the happy path here and unhappy path. Okay. So happy path is like this is the oplog, and it is going to give me the SQL statement, right? And unhappy path is like if the oplog having some is incorrect or it is not a valid oplog, then it should give me an error. So this is the at higher level at this point. These are the two things we need to cover, right? Now to start with, what exactly it does. So naming what should be the function or what I'm going to write at the first to start with. So naming is the very important part where and it should match the domain. So our domain is kind of what we are doing. We are converting the oplog to SQL. So it's generating, right? So maybe my function will look like generate or let's say it's an insert, right? So generate insert SQL. This is the function name, and what would be the parameter? It's the oplog, and it's a string, JSON string, and it will return string and error, right? Um, just returning nil to make compiler happy. Okay. Now, as a part of setup, if you install using the VS Code, there is a Go PLS utility where you can generate the unit test for this function. Once you have the signature, then it's a just one click where you can generate the test file for it. So you don't need to write the test from the scratch. Just come up with the signature, and then it will generate the test function for you. So right now I'm just removing this extra struct. I don't need it separate. I will just replace that with this one. Now, so this is my test function. I need to add the test example here, right? So what is the name of the test case? It's a insert operation, right? So insert operation, and oplog is this one. I'm just copy pasting the oplog from the problem statement. Right, and what I want this output. This is the SQL. Okay, and what error is false, because I'm not expecting error at this moment for this example at least. So this is the happy path for us, where it will successfully transfer the oplog to the SQL statement. If I run this test, it should fail, obviously, because we don't have any implementation. Okay, so test is failing for right reason, because as per implementation, we are just returning the empty string, right? So once we have this test function, let's go and write the code so that it will be pass the test case basically. Now, as you can see, this is the string and it's a JSON string. So we need to unmarshal it to get the structure out of it, right? Now, what is the structure of this oplog? If you look at this JSON, the structure should be, let me copy that. Yeah. So this is the oplog entry where it will have the OP, NS, and operation, right? OP, NS, and operation. And we need to unmarshal it so that we will initialize this structure, right? So let's unmarshal it. Okay. Now, once we unmarshal this object having all those operations, as per the story one, it's the operation is I. So I'm just adding the switch case here because in future it will be for update and delete. So just adding the case on oplog dot operation, right? And the case would be for I. Right. Now, for I, we need to generate this. The outcome should be like this. I'm just copy pasting it so that it will be easy. This is our expected output. So I'm just creating a one. We need the SQL string where it should be this one. Insert into as a first statement. I'm adding the space as well. Then we need to add the test dot student, which is the namespace in the oplog, right? This is ns. So I just simply use the fmt dot printer sentence and the okay. Right now I'm just returning this part so that just need to check what exactly is returning. I'm just running the test again. Okay, now it says this generates the insert into namespace, but we want the whole structure, right? So test is failing with the right reason. We didn't add any column names and the data yet. So let's move on to the next part. Now, this is the insert and namespace. How now we need to fetch the column names, and the column names are from the operation. So this is the map basically where key is the column name and value is the value of that particular column, right? So I'm just converting it into the map so that to extract the column names, and I already have that code. Okay, so this O is map, and I'm just ranging over that object operation and whatever. So we are skipping the value at the moment so that we are getting the column names, and I'm just appending the column names to the columns. And here I'm just need to SQL FMT percent yes. So this previous string I need as it is, and next to that I want column names, right? In bracket. So column names are in this array. So I need to join them using as a comma separator. Join column names separator will be right. So we have the column names as well. Let's run the test again. Okay, so this is our generated query, and this is our expected one. Okay, so till this part we are good. Now I need to add these values and the actual values there. I'm just adding values here. Okay, now how to extract the values from this JSON, right? The same way we did for the column names, we can have the values as well, column values, right? And then now instead of skipping these values, I'm just adding those and just appending value. Now it gives an error because the type of that value is the interface, and we are trying to append that to the string. Now need to convert that into the string. Let's do that. Just type casting it and percent yes. Same way, I'm just joining the values by comma. Okay, now our test should pass, right? Okay, it fails and actually it panics because the interface conversion from float is not a string. We are directly trying to typecast the value into the string where the type of this is the integer and this is the boolean, and hence it got panicked. So we cannot typecast this value in this way. So there is a other way of converting it, is the same way, like I'm doing this %v comma value. So using this formatter, it will convert into the string. The value will be converted into the string. And let's see that. Okay. Now it didn't panic, but the test got failed. It didn't pass as well. And the reason is, okay, so there are two reasons basically why the test got failed. One, if you look at the order of the columns, it's not matching with what we were expecting, right? And second, the values, those are not a string. I mean, those are not in the single quote. So those are not the strings. So string should be in the single quote and other values should be as it is. So we need to fix these two. And why this ordering is different? Because it's a map, right? So we cannot guarantee the order of those columns, which column will get inserted first and which one is next, right? So to fix that, what we will do, we will simply sort these columns, right? And once we sort, then the order should not be the problem. So let's fix these problems one at a time. So I'm just using the sort package. Okay. Now column names got sort, but we cannot have these column values, right? Because the values should be into the same order. Now, to deal with this, what we need to do, instead of extracting these values from here, let's do it in separate for loop. So I'm just doing this. This should be on this one, because this array is sorted now and we need to extract the values from, where is this column? This array. What exactly we need? We need the value from this map with this key column name. Now this is the slice. So the first object is index and second is the value. Okay. Now we have these column names. We joined it already. Let's see. Let's run the test again. Okay. Now it got fixed the order, right? Okay. Wait, we have in the expected output, we need to fix the order of the columns as well, because that is not in the sorted order. So we need to change the test. So changing the order into the test case itself. And so this is ID, date of birth should be the second one. Name, roll number is 51. That's it. So I changed the test case and let's run it again. Okay. So ordering problem is fixed. Now we need to add the single quote to the strings, but not for the other data types. Now, so which means we cannot use %v as it is. So there are formatters. If you look at, let me FMT formatters. So this formatter comes with different formatters basically, and those are for the different data types. So you can see that for integer, these are the %d is for integer, float boolean for is %t. So it's basically depending on the type, we need to change the formatter, right? So here, what I will do, I will just write the another function. For example, get column value, right? And I'm just pass the value of that column. So it should recognize the type and then return the string as expected. So I'm just getting it. It's the interface, right? Just copy pasting it from. And then having the switch case on the value where as per the type value dot type basically. And as per the type, I will return the string. For example, it's if it's a string, then it should be the single quote and the string, right? And for integer, what is it? Integer, I will return the fmt.sprintf %d value. Default, I am returning single quote v, so that I'm considering string as a default. Now with this implementation, if so there is no change, I call this function. Now let's run the test again. Okay, so it generates the, okay, it added the single quote for all. It didn't recognize type as an int. Okay, so it executed the default case. Let me add the other values, other types as well, or other flavors of the integer, so that we don't know which one it took. Right?
I think it didn't recognize the Boolean value.
Boolean as well as integer. So integer is also coming up with the single quote. So Boolean we will add. Okay. And let's add the case for Boolean. Boolean is %t. Okay, still 51 is in single quote.
When we JSON unmarshal it, it will not take as integer. It will take as float value.
Maybe float. Yeah,
64.
let me add the float 64. What? Okay, this is
%f.
okay for float. It's giving some error. Let's. What if we did %v? Now it is single quote. Okay, so it parsed the 51 properly. Okay, we're missing the semicolon. Where is the query? Yeah. Okay, and now our test is passed. Okay, in VS Code, wait a minute, to put the battery. Yeah, so this is our happy path where we are successfully translate this statement to the SQL, right? At the beginning, don't try to write the code as clean as possible, but go with the flow, complete the functionality first, and then later, whenever you find the code is becoming ugly, then do the round of refactoring. Once you have the work, the function, your code is functional, then go and refactor it. So whenever you have the test case, enough test cases, and then you have a code as well, then go, feel free to refactor that. And because you have test, you are confident on your refactoring. So there is a, in VS Code, you can hello,
Yeah, we can hear you, Kalpesh.
can you hear me?
Yes.
Okay. I think my laptop is my VS Code got crashed. Yes, just restarted it.
Okay. Yeah, we can still see the screen and we can hear you. No problem.
Okay. Yeah, so I was saying in VS Code, you can simply toggle the test coverage as well in your current package. So, oh, what happened? Right. So it shows you the what is covered in your test, whatever examples you have given, and what is not covered. So all these rates are not covered in your test case. So we don't have enough examples yet, which will cover these. So if we add some test cases for maybe invalid log, so that way it will be this this part will be covered. So I'm just copy pasting one example. So this is empty operation. And if I look at the coverage now, so coverage got increased, and you can see this line got covered. This is not still covered because whatever oplogs we have for insert, we have that. But I'm not adding as much other examples. You can go with while writing these examples before touching out to the next story or implementing more code functionality. Try to add as much as test cases possible in your test. So that way you will have the code coverage, and the percentage wise, it is not possible sometimes to cover 100%, but it's always good to have as much as percentage coverage percentage you will have the more confident on your code. So yeah, so this is our first story. I'm just committing this. Okay, so what we have done is feature, implement, generate, insert, log to SQL with test. Uh, okay, I'm just leaving this comment as of now. Okay, so
Kripesh, in the meantime, there are some questions. One is,
okay.
What was the extension used to generate the boilerplate for test code? Was there any extension, or is that some shortcut or some function
Yeah,
in
so
VS Code?
when you install the this Go extension, it comes up with the couple of tools, which includes the Go Pulse, Go PLS, and a couple of other tools as well. Which is, so if you install this, then those tools will be available for you.
Got it.
It is part of Go PLS. Yeah.
One more is, can you explain the line number 20, the if condition? What's the purpose of byte array and error checking on the same line? More like a beginner question, but
Which one?
line number 20.
20. Okay, I think
So that must be 22 now.
Okay, this one, unmarshalling. Yeah, it is just to make sure that whatever oplogs we are getting, it's not the invalid oplog. If so, the same way we added this test, right? The empty operation, and to make sure that whatever we are getting in as a this function, it should validate the input, and the purpose of this validation is same.
Okay. Cool. So just to summarize what we did, right? We looked at the first story, which is parsing the oplog, insert oplog, and convert that into SQL form. We, given the time, I think we should move to the next two stories, and feel free to sort of go through the story quickly, showcase what the story is about, and then go from there.
So next story is about the parsing the update oplog. The same way we had the insert, right? We have the update, the oplog for the update, but the difference here is if we look at the operation now, this object where it comes with this data percent $v and then div u. Actually, there are two types of update logs it generates. One is u inside the div and d inside the div. The meaning of u and d is whenever we update any existing column, existing field into the collection, it generates this kind of oplog. If we remove any field from the column, from the document, then it generates the oplog in this format. So this is the difference between two. And there is a new key added here, O2, which is used for the ID. So this is basically, we updated this document with ID this, and the difference is updating this column. So this is the meaning of the update oplog. So we will go one by one. First, we will tackle this update oplog. Let's go back. Again, same, I'm going to add the update operation. I'm adding the test case for update. So there are now, again, you can have option, because this is typically we have written this insert function separate. We can write the separate function for update as well. But at the same time, we need to, so this is the repeated work kind of, where we need to unmarshal that in that function as well. So instead of that, what we can do, so this is where the refactoring comes in. I can refactor this code like this, where I'm extracting this part, which is required for update as well, right? And making it more generic. Instead of insert, it's a generate SQL, right? And this is no longer required. This becomes here. I'm just calling this function here. Now I'm passing this object directly instead of string, and return the default one. What it will empty and accompanying error invalid oplog. Okay. I need to change the data type now, so it should be this one. Okay, so I just refactor the code, and what is the error here? Right, so this is no longer generate insert, it is generate SQL. Let's run the test again. test got passed, so we are good with the refactor. As a good practice, I always unexpose the functions which are not going to call from outside of the package. So I'm just making it unexposed. Okay. Okay. Now let's start implementing the update of log. Now this is the same function we are going to use. So I just copy paste this for update, and we'll change the upload accordingly. So this is update operation, right? And the upload should be this one. And expected output is this. Okay. Now, if I run the test, it is going to fail with the invalid upload because we don't have implementation for this. So I'm adding the case for you. And the same way I have implemented this insert, I will have the function for update. For now, I'm just copy pasting this and write it. This is our expected output. I'm just copy pasting it here so that way. Okay, so it starts with update, then the NS, which is this, and next is set. So I'm just adding set statement here, set keyword. And from here, we need to add the columns, and columns will be coming from O and div. Okay, so I'm not getting the, so from here, I will not get the key column as a key directly, but I will get the diff as a map because diff is a key and the value will be again another map of key and value where key is u and inside that there is a column and value basically. So it is kind of nested structure. So it will, I'm just to save the time, I'm just copy pasting the whatever implementation we have. So we need to again check whether this O or whatever structure we have, does it have the diff or not? It is kind of the validate the JSON or validate the uplog. I'm just removing this part. So I'm expecting diff. If it is not present, then obviously it's a invalid uplog. If diff is not present for the, I need to change this U. Insert to U for update. Now, once I get the diff, that means I'm getting this value. Again, it should be a U. So from this map, I need to extract the columns, the set columns basically. I'm calling it as a set map, just like this. It is a set map, but it should be from diff of U. Okay. Now, once I get this, I need to. So in this set map now, I have these columns as a key value, right? So I'm need to same way, I need to get the key and values from this column. Right. So this is values. I need to change the column. Wait, I don't need to do this because column name is from here and I'm getting the column value. Starting not required. So till this point, we could able to update, set, and the columns, right? And column is, this is name, value, set, and need to add the where clause now. Just remove this so that it will not confused. Now from where it will, so where clause is basically from the O2. So this is the key in the main oplock object. We have this key O2 from where we can get the where clause, right? So that is just where clause columns, and it should be outlook object dot O2. But we don't have O2 here, right? We need to add that. So O2 is basically again the map of string and interface. Okay. Now this is O2. Again, just copy pasting this for simplicity where so this way. Okay, now I get the column values here for setting purpose and where clause in this where columns, and our final statement where we need to append this string to the SQL, right? So just copy pasting it again. So this is our previous SQL statement as it is, where it is up to this, and we need to add the columns, right? So there might be possible we can have multiple columns. So strings dot join column values. This is our second percent yes, and then the where clause where to join again string dot join because it's a multiple columns. Right now it's a single, but it might be possible there will be a multiple columns. So and we need to add those with and, because in where clause we should have the and keyword instead of comma. So this is done. This is percent yes. Okay. Now let's see. Let's run the test again. It got failed. And what is the reason? Update is it is guaranteed equal to true where id is equal to 1. Okay. So
There's a double space after set, I think.
yeah, right. Why this and yeah, we have this space here and there as well. So yeah. Okay, still it got failed. Okay, because of the semicolon. Yeah. Yeah, so this got passed. Right. So we made the refactor as we see the scope of the refactoring after before starting the next taking the next story. And by looking at the next story only, we got to know that this part here, the unmarshalling part, right? It is going to used by both of the functions, and hence we refactor the code. So now we implemented the test for this set clause, right? There is another which we already did, sorry. So I'm just writing the test case for this as well, where it should be for unsetting the value for any for the column. So I'm just copy pasting. I'm saying this as a set, right? And this test becomes unset. So here, D is for unsetting, and the expected output is this one. If I run this now, it should fail, and which does. It says invalid log. And the reason is here, look at the update one. We have this check. If diff is you, then we are, if it's not you, then we are returning the invalid log. So we need to support the D as well. We need to add support for that as well, right? So I'm just copy pasting that from here. Else if, let's say, I need to move this here. If set map, okay, if it's okay, then do this. This needs to be for the else part. Unset map. This is your so always first write the code, the functional code, write the code where it will fulfill your requirement, and then later come again and refactor it. So for unset, what exactly we need to do? It needs to set the column value as a null. So here I don't need this value, and I can directly set to null. Okay. What is there now? Okay, so this column values is okay. So this variable is not accessible there. You see. So for now I'm just taking this statement there and make it compiler happy. Later we will just refactor it. I don't have
Line number
this part.
79. There's 81. You should use unset map, right?
Yeah, right. Yeah, I will just remove this part where clause is not required. This is unset. Right now, I need to add the where clause here. Okay, so for set, it will add the columns here, append it to this SQL string. For unset, okay. Now this should pass the test case, I believe. Yeah, so test got passed because now it's running fine. So whatever examples we have in the problem statement, we are able to run it properly. And let's see the test coverage. So the test coverage is now 87%. And the reason is obviously we don't have the test case where it checks if the diff is not available in the uplog. So we can add that to increase the test coverage. Then yeah, there are other places where obviously we don't have test cases for this. So yeah, it's okay to not cover all the part, but as a story writing, it might be possible. So as per this problem statement, we have covered only the happy path. So all the examples in this problem statement, those are with the happy path. But we, as a developer, we need to add the edge cases as well, write the test cases so that uh, it will cover all the edge cases. For example, this test case, it is right now just setting the one column at a time. But what if there are multiple columns? So whether our code will work fine with that or not, let's add the test case for the same. I'm saying update operation set with multiple columns, right? And I'm just adding the row. What are the other columns we have? So roll number, right? I'm just changing this to 21. Okay. So after adding one more test case, this got failed because, okay, I need to update that here as well, right? Roll number equal to 21. Okay, so this got passed. Again, let's say if I change the order in the map, again, this order of the columns is not guaranteed while reading or extracting those data from this map, but let's just try to change it and see. Okay, so it is still passing. It might be luckily it's passing but definitely it will causing the problem if the order of these columns is not as expected. So definitely we need to sort these columns so that way it should work. It will work as expected one. So before doing this, I'm just adding that sort statement. So that way here and here as well. Okay. Yeah, so this is all about story 2. Maybe we will refactor this code later because I think only 10 minutes are remaining, right? And we need to cover the one more story.
Yeah, so update was a bit complex, right? We
Yeah.
covered multiple cases. We also covered the AND part where you can update multiple values in a single. You can set multiple values or you can unset multiple values as well, possibly. Right? So that's why update is a bit more complicated. Uh, yeah, we can cover delete quickly and then
Yes.
just take a look at and summarize the whole what we've been doing, right? Like as a summary. Yeah.
Right. So again, if you look at the problem statement, story for delete is simple. The block for the delete is a simple one where we just have the object and in that we have the ID. The meaning of this block is this record or this document got deleted in the Mongo. So we need to delete this record from the Postgres as well. So let's, I'm just, before adding this, let me add the test case. Delete operation. And expected output is this. If I run the test got failed with the right reason. Let's add the code. And just copy pasting the delete implementation. This part should be like this actually. what we are expecting is the delete one. Yes. Okay, and then where and the ID. Okay, and ID is in the object. Okay, so this is the column should be O. This is column name, and this is the value, right? In SQL equal to center. Where clause join with, and just in case there are multiple columns, but in this case there will be always ID. So and then a semicolon. Return common. Okay, it got failed with delete from. Okay. Base issue. Okay, so this got passed, and if we look at the code coverage, it is 87.7, which is not bad. Okay, so these are the stories. 3 is also done. So what we started from the beginning, basically, we go through the problem statement, we read out the stories, and then we make sure that first setup is correct or not by just having the hello word, and then after that we write the signature for the story one, where what is the possible function signature for our story, which is insert of log, and from that story we come up with the function name, and then we generate the unit test using the extension again, so that it will save the time. We don't need to write all these implementation from the scratch. And then once we got that, we uh, copy pasted the input function, we input and the expected output from the problem statement, and then run the test case which got failed with the right reason, and then implemented the code into the function so that the test got passed. And after that, once we have the happy path return, we added few more edge cases like empty operation or invalid of logs. So we added the code for that as well. Added the test first and then make the test pass, change the code accordingly. So that way we have, so this is the cycle basically: write the test case, write the edge cases, and then implement, write the implementation. At this point, don't try to write the cleaner code, just make the function, make it work. Once it is work, then refactor it. There is a, before starting any story, try to, once we have enough test cases, then you have enough confidence to refactor the code. So that is the place where you can go ahead and refactor your code. So that is your cycle basically. So then we implemented the next stories like update having multiple flavors where it come up with update and delete the column. So we implemented that as well. There is a scope to reflect change or the refactor the code, but as I said, whenever we implement before starting implementing the new story, we will refactor that code into the next session. Delete was the simplest one, so we implemented that one. So I believe that's all. So next would be the creating table and for one upload. So this story we will cover the for story number 4, 5, and 5 is the creating table with multiple upload entries, and 6 is alter table with multiple upload entries. So these stories we will cover into the next session.
Right. Yeah, and as you said, right, like the SQL statement that is generated can be run directly on Postgres.
Yes,
Assuming we have the schema and the table created. That's
correct.
the main goal.
Yeah.
What we are trying to do is we are not trying to. I also want to highlight how we broke this problem down into multiple stories. Remember, TDD helps us focus on the core of the problem and not on the peripherals. If you look at what we've implemented so far, we've not even implemented anything that relates to connecting to MongoDB or connecting to Postgres, any of that. Right? We just straight away focused on the core business logic, which is if I have the uplog, how do I convert that into some sort of SQL statement? And then where I run that SQL statement, how I run it, how I get the uplog, all the input and output part of getting the data, getting the uploads, and then writing this final generated SQL to Postgres, MySQL, whatever relational database, that is all separate. That is all peripheral work, which we can do later point in time. So with tests driven development, it really sort of forces us to think of the core of the problem and then helps us tackle that part than worrying about the extraneous things on how do we get the input, because the way input you can read input and you can write output can change. You may be getting input from a file, you may be getting directly from the MongoDB or via a stream, for example. You may be writing the output to some file or directly executing the SQL statements on the database or vice versa, right? So writing tests first, we didn't get to spend a lot of time on is breaking the problem down to various stories, but that's a very core essence of TDD, where you before you write the first line of code, you have to kind of think a lot about what are you going to write the code for, what is the functionality that you want to build, how are you going to test it, right? So that is the essence of TDD that we want to demonstrate. In the next session, we'll focus on the next 3 stories. These are a bit difficult in terms of understanding the domain. So I would request, if you're attending, please go through those problem statements and try it out yourself. We'll be committing and pushing this code. I will send out an email later summarizing any uh, resources or whatever that you can use to take this ahead on your own as well. We'll have the next session on next Wednesday, same time, 6 p.m. IST, and we'd love for you to attend. We'll also send out a quick questionnaire, some sort of feedback form. I know we haven't had a good management today in terms of being able to respond to a lot of questions, and the live stream link had to change, but we'll try and take care of that from the next time. So hoping to see you guys there next time. If there's any question, please feel free to share it on Slido, and we would like to address that shortcomings, and if any, in the next session. All right. Thank you guys so much. See you next time. Keep learning. All right. Bye.
Thank you guys. Bye.